we're going to learn a little bit about connects, which is a query builder for JavaScript. I think that's the official term for it, is query builder. So those are our 4 objectives to tonight. Hope you've gone through and watched the videos, so you kind of understand what a relational database is already, but let's talk about it. So let's just talk about databases in general. What's the purpose of a database? And you can just throw this into Slack. All of my stuff, just throw it into Slack. What's the purpose of a database? Data storage, right? Data storage and persistence. I like that. Hold your data storage. Yeah. So we can, hold data in memory, right? We can hold data in an object in JavaScript in memory as our backend is running. But then what happens if our backend needs to restart for some reason? All of that data is wiped out. All right, so anything that we've saved is wiped out. And honestly, like for a lot of applications, a simple object storing data, not persisting between sessions, is fine. It's okay. But sometimes we need the ability to persist that data, to keep it for a long time, right? And so we use databases for that. Now, that's kind of a high level understanding of it. Persistence, of course, if you're not familiar with the word, just means that it's going to stick around. All right, that it's even if the database completely shuts down and starts back up again, that data is still there. So let's just say in a really high level way, what kind of databases have you used in the past? A thing that persists data, even when you shut it down and turn it back on. Well, those of you that have actually used real databases, we're not going to go there. But let's think about something that like literally everyone uses, a database that everyone uses. Simple text file. And really, where's that text file stored? Excel could be a database for sure. Excel is actually really similar to relational databases using SQL. Yeah, let's think about like our computer hard drives, right? Or even solid state memory on our phones, right? Those are all places that data has persisted. Okay, your Nintendo, 100%. Those of you that have used databases in the past, congrats, you have a head start on this. That's awesome. But we're really trying to go like super high level on here. So we want to take data or files or something and store it, and we want it to persist. All right. So that's really what the idea of a database is. Database has been around since the 60s. Digital database. Okay, I was going to say like there's probably been, if you use a looser version of the term, punch cards were databases, but yes, digital database has been around since the 60s, and actually SQL has been around since, I believe, the early 70s. Phone book is a database. Books are databases, right? Yeah, 100%. So now let's talk about a relational database. So there are different kinds of databases in the world. A relational database is one that has data that relates to each other, all right? So in a relational database, data is stored in tabular format, grouped into rows and columns, similar to a spreadsheet. So those of you that said Excel before, it's very similar to a relational database. Rows, tables, columns, et cetera, et cetera. If you're familiar with Excel, you can probably wrap your head around relational databases pretty easily. But let's talk about some main terminology when we talk about relational databases. First, we're going to talk about a table. So a table is going to be a group of like data, okay? So I'm going to bring you into this little thing in here. It's called DB Designer. It's pretty good for designing relational databases. So we're going to call this a table here. And this doesn't really do it all that much justice, but this is a table. Say we have a user table, and this user has an ID, has a name, and has a birthday. And that's it, okay? This is a table. These are our columns, okay? And I know that they don't really look like columns. I wish they'd flip it around. But we can even look, you know, SQL table, and let's go to images. Oh, these are very dry, dull images. I was hoping for some cool graphical thing. This is a table, right? So you have our row here. This whole thing's a table. These are our columns. All right. Columns, so the whole thing is going to be, say, users or customers or emails or something. You're going to have, usually you'll have an ID on it. And then you'll have, you know, imagine that these are objects where it's like, okay, well, every single object has that user's name, or this is allocation unit ID. Super exciting stuff here, whoever is doing this database. We have a type column, a description column, a container ID, etc. So these are our columns. So each row is a separate input of data, and each column determines what that data relates to, what it is, okay? So those are like the three big terms we have to understand when talking about relational database: tables, columns, and rows. So in here, organize data into rows and columns. It doesn't really tell us much about the table, what it is, but we'll see in just a moment. Each row in a table represents one distinct record. Okay, so that's our input. As we input data into our database, it's going to create new rows. All right. Each column represents a field, so we can think of that as like a key or a field or a property of that. And field should have descriptive name. Should definitely have a descriptive name. And one thing that's cool about relational databases, and with Postgres, this is well, it's not really blurred. It's distinct type. Okay, so all relational databases take a type. All right. So when we look back at this, we see that ID is always going to be an integer. All right. The name is going to be a string. Birth date is going to be a date. Okay. It takes a distinct type. These columns do, and it has to match that type. Let's see if we add a name. Let's go email, and we can look at the types. There's a bunch of different types. These are not the only types on here, but there's a difference between string and text. There's a difference between text and varchar. All right. So there are differences in these types, and if you get to designing your own database and your own tables, you're going to want to know the difference between those. But that's a little bit out of the scope of today's lesson. We'll just say text on that one, and we'll save that. We've added a new column to this designer. This is not an actual database. This is just the ability to design a database. All right. So question for you all. Relational databases are special in that we have the ability to relate data to each other. All right. That's what makes them amazing. And it's difficult to do that in other databases. It's not impossible, but it's difficult and not as easy as here. So how would we relate one table to another table? What's the way to go about doing that? Foreign keys? Yep. And what does foreign key mean? Like that's a pretty foreign concept. I see some typing, so I'm going to give it a moment. We're not doing joins yet. Yeah, so we're going to say, and you're not going to have to do this right away, but I just want to show you what makes And let's go. We're going to call this email. Let's save that. We're going to build another table, and we're going to say ID, auto increment, primary key. And we'll go integer on that. We'll add a field, and we'll say user ID. We'll call that an integer, and then we'll say foreign key. And this is going to reference the ID on the user. So now every email is going to be linked to a user. All right. So every email is going to be linked to a user. Paul, I apologize. I like to do things chaotically, and I like to see answers coming in real time. So my apologies to you and to everyone that loves threads. But yes, that's how I run things. Sorry. All right. So we now have the ability to relate data to each other, and we can build as many tables as we want and point them all at the user. We'll learn more about how to relate data to each other at a later time. But just to show you, that's what relation is in relational databases. All right. So that's kind of your rundown on relational databases. Are there any questions right now? Any questions on relational databases in general, before we dig into SQL? All right. No questions. So let's talk about SQL real quick. And then after this, we'll actually start writing some code. So who can tell me what SQL is, what it stands for? Yes, it stands for Structured Query Language. So SQL really describes the language we use to write the queries to manipulate and get and post data to our databases. Okay, so you'll often hear that, like, oh, that's a SQL database. Yeah, it just uses the SQL language to access data. Okay, so what are some SQL databases out there? I know you've already posted a bunch, but repost them. SQLite, which is what we're going to use today. Microsoft SQL, yep. MySQL, yep. Maria, is Maria a relational database? I thought it was a NoSQL database. I might be wrong. Postgres, 100%. I would say that those are I would say Microsoft SQL, MySQL, and Postgres are probably the three biggest ones out there right now. Mongo is not a SQL database. Mongo is a document. I can't think of the terminology right now. Document storage database. It's not SQL. But Microsoft SQL, MySQL, and Postgres are probably the three big ones. SQLite is really awesome for development. And there's a ton of apps that run production with SQLite as well. So that's totally valid. But Postgres is kind of the new golden child in the startup world. But you got there's the other two are also very popular. MySQL is really popular when PHP and WordPress were like the biggest things out there. They're still probably the biggest thing out there, but MySQL goes really well with PHP. It goes well with JavaScript too, but everyone seems to love Postgres. And that's because of its data types. But so those are some SQL databases. Those databases simply use the SQL language, okay? Standard language used to manage databases and data within them. Not all databases. I want to say relational databases for sure. De facto way to interact with a relational database. So SQL is its own language. We're going to learn the SQL language. SQL is very close to English, so that makes it pretty easy to start learning. It's not a brand new computer programming language. It allows us to do a few things. So it allows us to modify database objects, where we're going to use the create table, alter table, and drop table commands. It allows us to manipulate data stored in the database with insert, update, and delete. Most of the SQL stuff you're going to be using is either insert, update, delete, or select. Select is probably the biggest one. Yep. Apologize. So select is probably what you use most often. Select will allow us to get data out of our database, or access data from the database. Allows us to manage database security. You're not going to really use this. This isn't going to be the developer's role to do this stuff. As it even says here, that's the DBA, database administrator's role, where you're not really going to use it unless you become a database administrator. And then also with commit and rollback as well. So you really are going to use these insert, update, delete, select the most often, sometimes create table, alter table, and drop table. All right, and we'll learn what those mean in just a moment. So let me give you, restore the database, restore it. I'm going to give you this very simple, fun little W3 schools little sandbox environment here that has a SQL database built into it and allows us to write our own SQL statements. So if you want to follow along, feel free. Otherwise, just watch. So when we write a SQL statement, we first have to start with what we're doing, what we want, okay? We have a ton of data in here already. So say you're accessing a database here, and you're trying to get some data. So the first thing I'm going to do is select. I'm going to say select, and select is going to get data for us. Select means go access some data for us. Okay. Select. We're going to say select what? What do we want? And then we're going to say from and where we want it. Okay. So select something from somewhere. So this select I'm going to use right now is I'm going to select this asterisk. Does anyone know what the asterisk means in SQL? Yeah, all, everything. Get me everything, okay? That's what the asterisk means. And we're going to narrow it down in just a moment, but this is kind of the standard. Just go select all the rows, all of the columns from this table, okay? And then I'm going to say from where. Where do I want to select this from? And I want to give it a table. So I'm going to say customers. SQL is not going to work unless you put your semicolon on the end there. All right. So I say select everything from the table customers. Let's check it out. Boom. There we go. So here is everything in that table. Is this everything in our database? No, it's just in the customers table, okay? Just in the customers table. So let's go look. So what is this shaded line here called? The whole thing. What is that called? A record? Yeah. A row. We'd probably call it a row or a record, but a row. And this row, so each of these rows equal a brand new entry into the database. So all of this is about one customer, or it should be. All right, all of this is about one customer. So then we see we have our columns here. We have our customer ID, and so we can see the IDs of every customer going down. Ooh, there are a lot of customers, 91 of them. We have a customer name. All right, we have a contact name and address. So there's an address for each customer. City, postal code, and country. Okay, so that's great. We got all of the information. Sometimes, and most of the time, we do not want all of the information. We only want some of the information. So in order to do that, we can pick and choose which columns we want returned to us using this select statement. To do that, we simply write the columns out. So say I want contact name. So I can just say select contact name from customers, and let's see what we get. We get a big old table of just the contact names, okay? If I want to select more than one column, how do I do that? Yeah, comma separated, okay? So I'm gonna say, let's get our contact name, let's get our city, and let's get our customer name. So I can comma separate the columns I want from customers from the table, and then I can get all of those, just those, right? Just those three fields: contact name, city, and customer name. All right, pretty simple right now. We're gonna select something from somewhere. Okay. 1 second. I'm gonna put that back. And now let's say that I only want to get customers that are in London. How would I go about getting customers that are, or how do I go about narrowing down which rows I want? Yeah, so there's a third way of doing it, or there's a third item we can introduce called the where. So remember how I said SQL is English-like? We're going to select something from somewhere where we're going to say city equals, and we'll say London. Oop, and we've got to use single quotes. So I will tell you this, that SQL is a lot pickier than JavaScript. So keep that in mind. We need to use single quotes in SQL. All right. Yes, Mary, except for the single quotes, but yes. And so now we can see a list of all of our users' contact names and customer name that are living in London. All right. And what if we want Berlin instead? And we can see we have one Alfred's Fuderkeist is living in Berlin. Okay. We have one person. Let's actually remove this and we'll. And we can actually do a little bit of this. Are there any questions right now? Yeah, so convention is true. So you don't get mixed up, but it works either way. You will see it's probably best to write it with all caps for your commands. But you don't need to. Denton, do you mean as far as being able to access live databases? I'm going to show you something called SQLite Studio today. I like using, I don't know how you pronounce it, but Postico, but it's a Postgres viewer, essentially. And there are tons out there. I've used a few. Postico is probably my favorite at the moment. That's what I use for all of my personal projects. Any other questions right now? Okay. Oops, sorry. I preempted that. Delete. What I want you to do right now is write a query that will select the name field, the name column from the categories. You can see categories right here. The name field from the categories table where category ID is 2. And when you have it, I want you to post it in this thread. Everyone take a minute, write a query that it takes the name column only from categories where the ID is 2. The category ID is 2. If you have this pulled up, it's best. If not, there it is. We can look at all of our categories here. Give everyone another minute or two to write this out. All right, I'm going to take a couple and I'm going to just copy paste them. So I'm going to take one that I saw. Let's check this one out. Oh boy. My mouse is deciding to be a jerk. There we go. I'm going to take this one. Let's run it. And we get condiments. All right. And that should be what everyone gets. Let's do this one. This is copy pasted. I don't know whose it is. I just copy pasted it. And this isn't going to work just because ID isn't anything. So let's change this to category ID and let's see if it works now. Not working. Oh. Contact name. It should be, well, let's do, oh, it's category name, not contact name. Otherwise, you would have got it. All right, let's do another one. And there we go, condiments. Great. So we have grabbed the name from the categories where the ID is 2. Okay, so we got everything where the ID is too. This should be a unique category, right? We tend to think of IDs as unique. They're not. Well, yeah. We'll just leave it at that right now. So that's a good exercise. Come in here and start playing around with this. Select something from something where something else equals something. Okay, let's move on. Any questions about this right now? Okay. Does the ID need to be in single quotes? I tend to make sure that if it's a number that I leave it out of quotes, it should work. If it's in quotes, the ID, I don't know what data types these are either. So that's really up to the data type. Exactly. Let's move on here. We've got a list of products. How do I find every product where the price is under 50? So I'm going to say where, right? I'm going to say price. And how would I say under 50? I want to find every product where the price is under 50. Less than or equal to 50? Less than 50? I just want to say under, less than 50. Yeah, we can use our comparison operators in here, just like we would in JavaScript. So we're going to say where the price is less than 50. Okay, let's run that. And we'll see now, we should see, nothing over 50. Well, this works. This is exactly what we wanted. But now I want everything in order. What do I use to make everything in order? Yes, I can determine the order of things. So I can say order by. And remember, so this is a tricky one because this is both, these are one action here. All right, so where we've had before select from, where order by is one thing. Okay, so we're going to say order by, and let's just say price. So we can say ascending or descending. It is ascending by default. Let's run our query now, and we'll see that we get our cheapest price first, and we are ascending up our list all the way until the highest price item under 50. So if we can say descending if we want, and we'll start at the highest and we'll come down to the lowest. So without this, what is our query being ordered by right now? Yeah, the ID, right? We can see that it's being ordered by the ID. We can, if we wanted to, we can say order by product ID descending. So we can flip that around if we wanted to. Look at that. Now we have our largest ID on top, and it's descending to the lowest ID, regardless of the price. All right. We can order by anything in here. So let's go supplier ID. Now we will watch this column, and we'll see that our supplier ID is what we're ordering by. Pretty awesome stuff. So this is our SQL query language. We got a couple minutes left. We can keep on going. Any questions right now on this? So we have select something from somewhere where something matches, right? This is our filter that exists. The price of that column is that column is less than 50, and we are now ordering it by something. And I'll just go back to our price. Sorry if that was too small for you earlier. Hopefully that's better now. I see some typing, so I'm going to give it a moment. No more typing. Okay. Let's make this even, let's break this down even further. So let's say I want the 5 most expensive items under $50 in here. What can I add to this that only gives me the 5 most expensive items? Yeah, we're going to use one more, and it's called limit. So I can say limit 5. All right, and this is only going to give me the first 5 items that match this. So it's going to, so we got to really, let's look in here. You'll see it written like this quite often. So what it's going to do, what SQL's going to do is it's going to, first of all, it's going to select everything. Then it's going to find where this is true on those items and narrow it down. Then it's going to do this for us. And then finally, we're going to take all of those things that were in there and we're going to limit them to 5. And there we go. And now we have our 5 most expensive products under $50. What if I wanted my 5 most expensive products, period? What would I need to do to this query? Yeah, I would just remove this where, right? Because that where is what's limiting to things under 50. And so now these are my 5 most expensive products. Adric, yeah, that's another way. That's exactly what it is. So the first 5 rows that match this, what preceded it, okay? What if I want to find the 5 cheapest products? Brian, range, you can do range. You can do where something and something. We're not getting there right now. Yeah, we just changed this descending to ascending. And now it's going to give us the 5 least expensive products. Pretty cool stuff. We've taken this whole categories. I know we've taken products, excuse me. There's 77 products in there. And we have determined we wanted the 5 least expensive products in this list. All right. And there we go. Pretty awesome. Any questions right now on this? We're not going to use max and min right now. Those are more advanced than what we are dealing with. But by all means, if you have it already mastered the basic query, go ahead and use max and min. We're not using any functions right now. All right. So honestly, I really think that W3 schools, their SQL stuff is awesome for learners. So you can come in here and learn all you want, and we're not worrying about joins. We can see where. Let's go to the where, and it'll tell you exactly how where is used, how to use it, and then allow you to do this. So if you have any other want to learn a little bit more, come into W3 Schools. If you go to the official documentation for like Postgres, you are going to be blindsided. It is very technical. It is very academic, and it's hard to understand as a learner. So I highly suggest W3 Schools SQL stuff. It's really good for learning. So let's go find select. So we can learn all about select in here, and we get some examples. So that's what we're gonna cover with select today. Right now, let's take a 5-minute break. Come back and we'll learn about insert and update. All right, see you in 5. All right, come on back, and we will continue our exploration of the SQL language. Okay, so now we understand how to access data from our database from customers. Okay, we know how to access data from the database. We can refine our query in order to get the exact data we need. What if we went where city equals, is that how you spell Phoenix? I always get it wrong. No. Phoenix. Nope, that's definitely wrong. Tucson. We're going to run it, and there's nothing here, right? Because there's nothing that matches that. So we'll get no result. Later on in Connects, we will get an empty array. But for right now, we get nothing. Okay, cool. You ask for something, it doesn't exist. Okay. So keep that in mind as well. So we know how to get data out. Now let's learn how to put data in. What is the keyword I need to use in order to put data into our database? Yeah, it's insert, and more specifically, insert into. Insert into. This one's kind of tricky because you would think that it would say insert, something into somewhere, right? That's how select goes. But in this case, we do insert into. Okay. Insert into, and what's next? What comes after insert into? Yeah, where we want to insert it, right? We're gonna put some data in, and we want to tell it where to insert it. Insert into, and let's go customers. And then we need to give it a list of the columns that we are going to insert data to. Okay. So let's go. We do that by using parentheses, and then we give it a list of data or of columns. So we're going to say country, customer name, contact name, address, city, postal code. Why am I not inserting a customer ID into here? Does anybody know? Yeah, in our case here, our database is actually going to create that ID for us. And so most of the time, your database is going to create that ID. It is, as a number of you mentioned, the primary key, auto increments. We could have a function that creates a hash for it instead of just a incrementing number. But yeah, that's really going to be taken care of by our database. And unless we specify otherwise, usually that's what happens. Okay. But everything else we can put in. Okay. So we're going to insert into the customers table. Oh. Now, does it matter what order I tell it the columns are in? Ooh, it does. How so? This is kind of a trick question because it does and it doesn't. I see several people typing before I move on. I want to see what you all have to say. For those of you that are sticklers for order and compliance and things in the right place, this might be throwing you off. But it doesn't matter as far as the table is concerned. It does matter as far as the data I'm about to feed it. You can think of this just like function parameters. Okay, where I'm going to give it an order in here, and where I put the data in is going to need to be in the same order. It doesn't necessarily need to be in the order that is listed on our table. Okay. Yep. So we can give these out of order of what's listed on our table, but we need to make sure that we give the data in that same order. Speaking of data, how do I provide data? What keyword do I need to use to provide data to this insert? Yep, we're going to use the keyword of values. And we essentially give it another parentheses and then pass those values in. Remember, they do need to be in this order. Okay. Need to be in that same order. So I'm going to say values, and I'm going to say USA. Lambda school. Dan Frehner. Oh no. One fake street. Jackson. Okay. So we can see here we have insert into the table we're going to insert this into. We are going to give it the exact columns we want to insert data into in that table. We're going to use the values keyword, and then we're going to provide a parentheses wrapped, comma separated list of the values that we want to insert one-to-one on those columns. Okay, so USA is going to go for country. Lambda school is going to go for customer name. Contact name, Dan Frehner. One fake street is address. Jackson is city. Postal code is 83001. Okay. Let's run that. So when you do an insert, you usually get like some really like menial, like something like rows affected. You might just get one back. It's not even gonna say rows affected one. It'll just say one or success, right? So let's remove that and let's go select from customers. Customers. Let's go look. And we can see here, Lambda School Dan Frehner, our value has been added. And post or whatever database this is, I'm not sure what they're using, probably SQLite, has given us a auto-generated ID. Any questions on insert into? Ooh, no, it's not ID, it's customer ID. Okay. I'm going to move this over. Right there. Now let's say I want contact name. I want it to be my full name. I want it to be Daniel Frehner. I was like, oh, someone went in here and put me in there as Dan Frehner, but I need it to be legally for compliance issues. I need it to be Daniel. What do I need to do to this row? Yes, we need to update this row. So we are going to say update. All right. And this one's kind of a tricky one. Update is a weird one that you might have to look up the syntax for often when you use it, unless you're a star SQL coder. So we're going to say update, and we're going to say update customers. We're going to tell it the table we want to update. All right. And then we're going to say set and the column we want to update. Contact name. And we're going to give it an equal sign and then what we want to update it to. Now, if I pressed run SQL right now, what is going to happen? Yeah, it's going to set every row to Daniel Frehner, the contact name to Daniel Frehner. So I do need to limit this. How would I limit it to only our Lambda School row? Yeah, I can use a where and an update as well. So we can think of update's a little bit more like a select than an insert is. So we can say where. I can say customer ID equals 92. I can say contact name equals Dan Frehner, right? Yeah. Yes. Make sure that when you're learning SQL that you play around with not important data. So now we're going to see you've made it changes to the database. Rows affected 1. So I'm going to take that. I'm going to remove it. I'm going to post that in my handy dandy place I've been holding things. I'm going to bring this back in. And now let's check it out. We have updated it. If you want to see what happens when you don't have that, rows affected 92. Oh no, I have severely screwed this up. 92 is not as bad as if you see like 920,000 or something like that. You're like, uh-oh. I hope that we've made a lot of backups of our database. Databases are where people run into serious issues with this stuff. So and then let's go check it out. Oh no, everyone's name is Daniel Frehner now in our database here. Okay. And you can't fix that. You can't reverse that. So keep that in mind. The only way you can reverse it if you may have made backups of your database. Which we have. Boom. Let's restore it. Now we're just going to miss our Lambda School one. No big deal. Okay. Final thing we need to figure out how to do. Does anyone know what it is? Delete. Ooh, this is a scary one. Delete is scary when it comes to databases. Because as you've seen, databases don't give you a whole lot of like, are you sure you really want to do that? Like, you're about to update 92 rows. Is that what you really wanted? No, it just doesn't. Okay. So delete is kind of scary, but we can, learn how to do it here and then not have to worry about the consequences. Well, we will have to worry about the consequences, but not have to worry about messing it up later on down the line. So first of all, we're going to use the delete keyword. And this one's going to be more like insert. We're going to say delete from And let's give customers. What if I just did this? Do not drop. I would highly suggest that nobody types the word drop unless you know exactly what it does. So let's check this out. Uh-oh. Oh no. I wanted to get rid of one, but I have gotten rid of everything. All right. Oh, wait. No result. I've deleted everything. Oh my gosh, my entire business is going under. Our entire startup has failed. The company is gone. And then thankfully, our sysadmin or DevOps guy has, or gal, has rotating backups every couple minutes. So we're good. Whew. Thought I ruined everything. Now we're here. Okay. So we're going to delete from customers where we can do anything. What columns should we delete from? Any of these columns. It's up to you. First one up gets it. City. Where city equals, and what city do you want to delete? Every user from a certain city. London. All right. We're going to delete where the city is London. We're like, uh-oh. Brexit has taken a toll and we are not allowed to have UK customers anymore. We have to get rid of them all right now. Okay. So we are going to delete every row. Remember, it's going to delete every single row that matches our query after this. Okay. So we have deleted 6 rows. All right. Select from customers. And now we will see, we shouldn't see any Londons on here. And we can even check this to make sure where city equals London. And we should get no results. Okay. Any questions about select, insert into, update, or delete? Everyone's good? Everyone got it? Everyone ready to write your own deletes and your own inserts and updates and selects and all your own queries? Let me just say that for the most part, you're not going to be writing what we call raw SQL like this. All right. So we call this raw SQL. You could be, and you very well could write this in your Express app, and you can get your whatever database you're using. You can get its npm wrapper, and you can just write in raw SQL directly into it. But for the most part, we don't really do it, especially with Node. Well, with anything. We're going to use a couple of different libraries. First of all, there's a library, there's a type of a library called an ORM. And so let's look at an ORM real quick. So an ORM stands for Object Relational Mapper, I believe. Oh boy, hope I didn't screw that one up. So Sequelize is probably the most common ORM for Node. And it is going to allow us to essentially build models and build tables and really map everything we want into our database into JavaScript. Okay. And then it is going to do all of the heavy lifting for us when it comes to manipulating and accessing data in our database. Okay, so an ORM is very heavy-handed. Let's go to our documentation. The ORMs are really heavy-handed, where we're going to see stuff like this. We're going to build a user class that's going to, we're going to give it what we want. So this is going to build a table called user. We're going to put a username and a birthday in it. We're going to call it user. And then when we want to access something, we are going to use the SQLized way of accessing it, okay? So this is an ORM, this is a full ORM. And whatever company you work for after Lambda very well could be using SQLized or Type ORM, or I believe Bookshelf is an ORM as well. And so that's very common. If you have ever used Mongo in the past, probably use Mongoose, and Mongoose is an ORM. All right, even though Mongo is not a relational database, and so that's kind of this is the I'll call this the Angular of the database world. We're going to use the React of the database world, and it's a library called Connects. Connects.js. Well, it should have just popped up for me, but whatever. Here we go. So we're going to use a library called Connects. And Connects is the low level, we are just going to create queries and that's it. Okay. Object relational model. Yeah. That's I believe I said that. But so Connects is what's called a query builder. Query builder is going to allow us to not have to write raw SQL over and over and over again. And I believe Connects was named after the Connects toys. So, and I think that's why their logo is one of those Connects toys. I actually never noticed their logo until right now. So Connects is going to allow us to build queries in a JavaScript fashion. It's not going to make us write raw SQL like this. We are going to be able to write it much more concise. And yeah, it's just overall a joy to use Connects, honestly. I really enjoy using it. I was always under the ORM type of thing. And then when I started working at Lambda, we were talking about Connects. And when we started writing the curriculum, I was like, oh my gosh, why haven't I been using this before? So I love Connects. So let's go look at what our queries are going to look like in Connects. So they're going to be a little bit different looking than, and let's actually get this bigger. So let's look at something like, oh, that's too complex. I wanted some very simple, non-super complex stuff. All right, here is a very non-complex query that we are going to write. So Connects is going to grab the table called users. This is automatically going to be a select for us. So we don't have to worry about writing select. We can write select if we want, okay? But it's just going to select this table. It's going to select everything on that table. And then we're going to say .where ID is, in this case, where ID is 1. All right? So where ID is equal to 1, and then give us the first item. All right, so this is a lot simpler to write than select star from users where ID equals 1, limit by 1, or limit 1, all right? So anything we can do in SQL, we can do in Connects. The cool thing about Connects as well, let's go to the very top, is that it works for all of these relational databases. We can use this with Postgres. We can use this with Microsoft SQL. We can use this with MySQL, Maria. So Maria is a relational database. SQLite, Oracle, Redshift on AWS. We can use this And we can write this code once, and for some things, there's a little like advanced SQL stuff. There's a little like back and forth, like a little, tweaking you need to do to make it fit. Let's say Postgres instead of SQLite. But for all of the basic querying stuff, it's all the same. So connextjs.org is where you're going to find your documentation. You are going to reference this a lot. You can look at all of these methods that are on here. It's pretty awesome to be able to write your queries very, very simply and quickly. So what we're going to do is we're going to work on a little project ourselves. Let me give you the actual project. Feel free to clone that down if you would like to follow along, and I will pause, stop sharing. Give me a moment to set up here. While we're waiting, if you want to clone that. Clear that. All right. I apologize for the screen size. I have made it all of our fonts big enough to be able to see. And let me share. Okay. Just a quick check. Anyone having an issue with the size of the font on any of these three screens? This is our most important one here. On this one? Okay, that's fine. That works. And our terminal isn't really going to do much. We're not going to be messing with it very much. Yeah, sorry, this is a wide monitor, but I've seemed to have had good success with it in the past with students, so. Let me just do that. So Jimmy, can you make out the font on the text on the VS Code here? Or does it need to be bigger still? There we go. All right. That hopefully should be good. All right. So after you clone it down, you will need to install Connects and SQLite 3. Okay. With that install, you'll also need to npm install in general, just so you can get Express down as well. But that should be the only thing you really need. We are using NodeMon. If you don't have NodeMon installed globally, then that'll install that for you as well. Sean, the -s is save, so that it will save it into our dependencies. If you're not using Yarn, Yarn saves it automatically. npm, you will need to save it. Okay, so let's just do npm run server. We can see here that server is going to start our nodemon with our index.js. And we should be good to go. All right. So let's go take a look at our server here. It's a pretty simple server. We are going to use the API/posts. So when we hit a route that is /API/posts, we're going to use our post router. We'll go in there in a moment. Otherwise, we're just going to use our, we're just going to send some basic JavaScript back. So we can come into here, localhost 4000, I believe is what we're running on. Yep. Send. And we should get our basic. Has everyone used Postman here? Anybody that has not used Postman? If you haven't used Postman, I highly suggest getting it, downloading it. It will allow you to work on your back end really easily and allow you to test your routes really easily. Cool. So essentially, I'm just sending a GET request to localhost at port 4000, and we are getting what we believe we should be getting, DB helpers with connect. Okay. So what I want to do is I want to first show you this data folder and our DB config. This is where our configuration happens for connects. We are going to be talking about this in the next lesson on Thursday. And you'll be talking about that with Sean. But just know that this exists, and this is where we are connecting to our database. Connecting to it through here, and then actually through what's called a connects file, which is going to connect to the actual. So since we're using SQLite, we're connecting to an actual file. Yep. That one didn't, that doesn't zoom very well, but we'll get there. Okay. So that's all we really need to know about what's happening. Right now, we're exporting our database connection, and then we are going to import it as DB in our posts. Okay, so let's go look at our post router, and remember, this is where our /API/post is coming from. So let's come in here to our post router, and we will see that we are given 5 routes. Now we're giving a get with just a regular, so that's going to be API/posts/ that's our get. API/post/ an ID is going to be this route. A post with our regular, a put with the ID, and a delete with our ID. Okay. So let's start this off by just accessing our posts. All right. So we can see here that we are importing this data config. Remember, we are exporting it. We're exporting the connection. Okay, so this is actually connecting to our database, and we are exporting the entire connection, and we're importing that connection now and assigning it to something called a VB. All right. So let's go and take a look at how we do. First of all, I'm going to say const posts equals DB. And remember, in our documentation, we could say connects or DB here, and we can just give the name of the table we wanted to connect to. So in this case, it's going to be posts. All right. So one thing about databases is that every single time we access a database, it is going to be an asynchronous call. All right. So no matter what, no matter if it's SQLite and it's blazing fast, SQLite is very fast, or if it's this massive offsite Oracle database, it's always going to be an asynchronous call. So because it's an asynchronous call, what is this call going to return to us? Here, when I ask it to get me all of the rows from the post column, what is this going to return? Yes, it is going to return a promise. Are we familiar with the async await syntax? Is anyone really not familiar with it? Okay, cool. So let me write this out in two different ways. I'm going to first write it out as a promise. So I'm going to say dot posts, and then I'll say dot then. So I'm going to access this, and then let's just response. It'll be posts, so I'll call it posts, and then let's just console log posts. Okay. And then I'll say dot catch error console log error, and I'll switch this over to async await in just a moment. All right, so in this case, I'm going to just grab the post. It's going to return a promise, and then once that promise is returned, it's going to give us our post back, and we'll see it logged over here. Let's go /API/posts. And we shouldn't actually get anything. It should just hang on us for a moment. Sending requests. Oh, where's our posts at? Let's cancel that. Should come out to us. Okay, so this is how we would do it with promises. Let's do it with async await. With async await, we just need to tell the whatever, in this case it's Node, the V8 engine, that this function is going to be an asynchronous function. There are going to be asynchronous things happening inside this function. So in order to do that, we just give it the async before the function. All right. Now, instead of writing dot then and dot catch, we can actually just assign a variable to that promise, and we can say await. So it will wait for it to resolve, and when it resolves, it will give this whatever it was going to give the dot then. Okay, so that's it. It's just syntactic sugar, really, is what it is. It just allows us to not write dot then and dot catch, although we still write dot try, or we write try and catch. We'll see that in just a moment. So let's go console log here. All right. Let's send, and I'm going to just do just give it a 200, just so it doesn't hang on us forever. All right, let's send that. And now we see we have all of our posts in here. Oh, why didn't it send? Huh. We have, now it's gone and gotten all of our posts, okay? Also look at what our posts are in. So connects is automatically gonna put everything in an array. So we're gonna get an array of objects, and each of these is its own post. All right, so each of these is its own row, its own document here. Send status is the old way of writing it. You used to have to write send status. No, it's still, I don't know why it's not doing that. Looks like it should have given us a status. Okay, we got our status. All right, I don't know why it didn't just allow me to write status. It usually does. But the main thing is that we now have gotten our posts. So await is just going to await for this promise to resolve, and then it's going to give us whatever it resolves to, and we can assign it to a variable. Okay, that's how async await works. If you're more comfortable using promises, by all means use promises. If you're more comfortable using async await, use async await. It's whatever works for you. Okay, let's take a quick break. If you do have any questions, please post them in Slack. Let's get that back up. Oh, we already got a timer up. Let's take 5. We'll come back and we will build out our little API server here. 5 minutes. I'll see you then. All right, let's come on back. We'll build out our back end here, and we will, I'm actually going to move this over there because I don't care about our terminal any longer. I want to see Postman, and there we go. Okay, so in this case, router.get, we want to get all posts. We now see that we can use DB and then just give it the name of the table we want. And this is essentially the same as writing select from posts, right? We can, if we want to, write dot select and then give it, and then dot, I believe it's from posts. So we can write it like this if we'd like to. If that makes more sense to you, then by all means, you can write it like that. But you don't need to. That's the beauty about connects. Connects can be a little difficult to really pinpoint exactly what you want because there are multiple ways to do almost everything in here. But right now, we're just going to do a pretty simple select. This is going to select all of the rows from our posts and give it back to us, okay? In this case, let's do posts, and I'm going to .json posts. All right, I'll save that. Let's come in here, and there we go. We now have all of our posts back to us. So that's gone in, accessed our database, found all of the rows in that post. One other thing I want to talk about with async await is that we must use a try catch block. So we don't have to use .then and .catch, but we must use a try catch. So try is going to try this first. If this fails, if this await fails here, it will throw an error and pass it to our catch block, okay? Like I said, if you're more familiar with, or more comfortable with promises, by all means, use promises for this. That's fine as well. In this case, I'm going to status 500, and then JSON this thing, and give it a message failed to get posts. So if I do something like this, I'll save that. We should get a message failed to get posts. Save that, send it, and there we go. Any questions on this right now? This is a simple get. We're just selecting all from our one table. Let's narrow our search down a little bit then. All right. First, I'm going to make this an asynchronous function. I'm going to write our try catch blocks off the bat. Okay. And now let's go. We want to get a single post, right? We want to get one by that specific ID. So let's write out what our SQL would look like. What would our SQL look like if we wanted to get something by an ID? We have select star from posts. And what comes next? Not ID yet. Yeah, we need that where. Then our ID. ID equals, whatever ID we get, right? Let's say 16. That's how we would write it in SQL. So I recommend that when you're writing something out, write it out, and then be like, okay, I know where to get how that works. It's just that. How does this work? And then you can go to your connects. You can go and look at where, and you can see exactly how it works. You can do where a number of different ways. You can give it an object of key value pairs. So where first name is this and last name is that. That's an and in there. Or you can give it a single string of the column you want and the item you want to select. Okay. So we're going to do it this way. But that's a good habit to get into when you are writing this stuff out, is write the actual SQL out, write what the SQL would be, and then look at the pieces that you don't quite know in connects, and go look at the documentation for it. So let's go const post. And how am I going to write this out? What's the first thing I'm going to write? Ah, yes. You caught me off guard. Now what do I write? How do I begin this query? Yep, I'm going to go DB, and I'm going to grab it from the posts. And now I can change the where onto that. So that's going to grab all of the items, and then the where is going to limit my search. We're going to say ID, and then I'm actually going to grab the ID from my params. So let's go const ID rec.params. And I can just put that ID in there now. So our ID that's coming in here is going to be saved on our request.params. And then we're just going to grab that. Now we can say get that all posts where ID is equal to whatever ID we've given it. Okay. Any questions on that? Are you familiar with this syntax? Grabbing our parameter. Yeah, we could have done that. Absolutely. We could have done rec.params.id. That works too. Exact same way. We'll usually use this syntax when there's more than one parameter we need to get. Yep. We'll save that for right now. Let's console log. Let's just send it. res.json post. Okay. Does anybody know what data type this is going to return to us? Well, we'll send it as JSON later, but this data type right here, let's check it out. Gives us an array. Even though it's only one item, Connects is always going to give us an array when we do a query. Okay. Always going to give us an array when we do a query, and then it's going to be an array with a single object in it. So we can destructure that array if we want, and just get the object out of it if we know that it's only going to be one item. Okay. Otherwise, we are going to only get the first item out of there. So just keep that in mind when you do query. It's always going to give you an array back. And you might be like, why isn't this working? It's not like giving me the exact object I want back, but it is. It's just in an array. Okay, so keep that in mind. All right. So let's come down here to post. First thing I'm going to do, async. I'm going to do a try catch. So let's think about how a post is going to be structured. You can do first. Yes, you can do first as well. So how is post going to be structured? Well, we're probably going to get a body, right, of data. And then we are going to want to give that to our array. So let's come in here real quick and let's just go post data rec.body. All right, so we're going to see our entire body is going to be the data we want. All right, this isn't going to work for a production app always, because what if you get erroneous data in here that you don't need? So we do want to insert. How do we insert? Well, using connects, it's very simple. We're going to say const post equals await db posts. So this is going to be a select for us, but when I say dot insert, it now becomes an insert for us. So connect can be a little bit confusing at first because you're like, well, that's a select. How are we inserting into a select? But when it sees insert, it automatically turns this into, I'm inserting into posts. Okay. Let's go look at our insert docs. So let's come on over here. Insert. Also, I think my favorite thing about the connects docs is this is one entire giant page. Literally, all of the docs are on one page. So if you're looking for insert, just Control F and find insert. Batch insert, that's not what I'm looking for. Or you can come over here. I do love that about connects. Okay, so insert is going to take an object with key value pairs as items to insert into this table. So we don't have to type insert into, we don't have to name, look at that, we don't have to name the columns we want to insert into. That's automatically done by the key in here. So it takes the key and it does this for us. It takes the value and it does this for us. It's a pretty awesome system here. So we're just going to give it an object of key value pairs, and it's going to take care of all of the hard work for us. All right. So there's, yeah. Any questions on that? It's pretty awesome. Connects is great when it comes to stuff like this. All right, let's go insert it. Insert, and we're just going to pass post data to it. Okay. So in our case here, we are going to need to post body raw JSON. I'm going to write some raw JSON. I need to give it a title. Bands post. And I need to give it contents. Fake contents. After our post, we are going to send a status. Does anybody know what status we would use in order to tell it that it was okay and that their post worked? Ooh, you guys were on the ready with that. Yes, it's a 201. Means the whatever we were asking it to add was added successfully. And we can say JSON, let's just say post in this. Failed to insert post. Okay. Let's see what we get back. Let's send it. Error cannot post to, oh yes, I'm not posting to a single item. And what we're getting back is the ID of the new item. Successful update, I'm sure there is. My go-to is always Wikipedia, HTTP code. Wikipedia is my favorite source for it. It's so easy just to like, see successful, accepted, reset content, maybe not. I would say just an okay. 201 is created. It means the item you wanted to insert into the database has been done successfully. Accepted could be, no, that's not really fit for update. I would say 200 is probably the best bet for update. Yeah. Okay, now we can go. Let's get all of our posts and let's go look. And there we go. Our post has been created. Also look at what fields did our database create for us? And you're going to learn how to set up your database to create these fields for you next time. Yeah, it gave us ID, it gave us created at, and it gave us updated at. Okay. And these are all automatically given to us. So now we can, if we wanted to, we can say like, give me the most recent post in select star from posts where, created at is greater than or order by descending limit 1, right? And that's going to give us the it's going to give us the latest post. Really cool stuff you can do. We're running out of time here, but I want to get to all of these real quick. So let's come back down to put here. All right. So we need to grab our ID. rec.params, grabbed our ID, and now we need to update something. So remember what update gives us back. What did update give us back when we were using W3 schools? What data did it give us back? Yeah, the amount of rows affected, the amount of records updated. Remember when we said update, where name is Daniel Frehner and it updated 92. It's going to give us the same back with connects here. So we can just say rows updated. We're going to wait, database, posts. So if I just say update, and I say rec.body, what is that going to do for us? It's going to update everything. It's going to make every single post rec.body, whatever we want to update it to. So what we have to do, yes, Natalie, all the posts. What we have to do is we have to put a where in here. So now we're chaining multiple things, and you can chain as many of these as you want. That's why it's called a query builder. We can build our query, and there are some wildly large queries out there, like hundreds of lines long, okay? So we're gonna say update where, and we can just say ID is ID. We can say where ID is ID, which actually shorthands to this. Either way is fine. I'm gonna do it this way because we're only using one. Now let's res dot status is going to be 200. Yeah, we can do 200 dot JSON. And we'll go updated count. Oh, rows updated. We'll throw another error into there. Okay, so now let's come and let's put, we have a body in here, updated. All right, we are going to, we know what that is. I believe it's 14. So we're going to have to put our parameter in as 14. We'll send that. And now we get back updated 1 record. Thank goodness. Because if it said 14 records, then we knew we had screwed up somewhere. Patrick, it will, but we're going to learn about seeding stuff in the next lecture. You don't have to worry about, oh, wait, if you actually really did delete all your data, then yeah, seed it. That's fine. Okay. Sorry, I thought we were getting ahead of ourselves, but I didn't know if Nathan actually deleted all their data or not. Okay, one more, and we'll be done for the evening. Hey, sync. Yes, then follow Patrick's command, and you'll be good. Or you can reclone. Or, yeah. Catch, error. All right, once again, delete is going to give us a count as well. Rows deleted. Posts. All right, there's a couple of different ways we can do this. We can use the, and I'm sorry we're gonna run a couple minutes over, but we can use the dot delete, or we can just use del. You're gonna see del used most often. So if I say del, this is actually going to, probably what Nathan did. Maybe, maybe not. This is going to delete everything, right? We need to make sure that we limit it to the item we want to delete. So yeah, we can just do it this way. Once again, we're going to use our where ID. And that will now delete only where the ID is that one item. Okay. And res.json, deleted records, rows deleted. So this is now going to go in there where this ID is equal to the ID that we've given it in the parameters is going to delete that record. There is no backup. There is no anything. That record is going to be deleted forever. Okay, so keep that in mind. So if I come in here and I say delete 14, let's send that off. We now get deleted records 1. Let's go get. We're going to say get 14. We're not going to get anything back. We would put a 404 there. And we can see that 14 is now gone. All right. Any questions on any of these? On what we're doing here with connects? With our project, we are just writing our connects queries. We're not worried about setting it up. Yeah, we can do a status code. I would say a status code for delete is probably the same. It's 200. Let's go see. It's nothing in 1.0s. No content. No, we are returning some content, so we're not going to say no content. So I would just say okay on the deleted. There's no specific, this item has been deleted status code. Yep. Any other questions? All right. That's what I've got for you tonight. Thanks for joining me and letting me jump in and take over for Sean for a night. I hope you're as excited as I am to play with relational databases. Databases are really cool. Playing with them is really cool. It can be a little frustrating sometimes, but taking it slow and just really starting to learn the systems and learn how everything works is the key to really understanding it better in the long run. So don't rush things. Just take it slow, one step at a time, and yeah, have fun with it. Thanks, everyone. Have a good night. We'll see you later.